Good evening. Today we are going to see the problems which are from exercise 1 of unit 3, and these problems are on bending stresses. So unit 3 we are with bending and shear stresses. Today we will see exercise 1 on bending stresses. So cantilever beam AB is loaded by a couple M0 at its free end. The length of the beam is 1.5 meter. So we have given that is L is 1.5 meter, and the longitudinal strain at the top surface is zero point 0.1. So we have length as 1.5 meter, length as 1.5 meter, and strain we have 0.001. And then the distance between the top surface to the neutral axis is given 75 millimeter. Calculate the radius of curvature. L is 1500 mm, strain is 0.001, y is 75 mm, that is 75 into 10 raised to minus 3 meters. Then we have flexural formula. We have sigma by y is equal to m by I is equal to E by R. Now we are interested with the terms in this, that is sigma by y is equal to E by R. So we are going to use these two terms from the formula, and from this, so if we will see this, so we have sigma by y is equal to E by R, and therefore we will get R is equal to E by sigma into y. Now we know we have sigma directly proportional to strain, or we can have sigma is equal to E epsilon, and therefore we will get E upon sigma, and that is equal to 1 upon epsilon. And this we are going to use to calculate the value of R. So E upon sigma, we have 1 upon epsilon into y, and then we will substitute the values. R equal to, therefore, 1 upon 0.001 into 75 into 10 raised to minus 3, and we will get R equal to 75 meters. So from this, because these values we have in meters, and from this we will get R that is equal to 75 meters. Then second problem, we have a copper wire having diameter 3 millimeter is bent into a circle with the ends touching. If the maximum permissible strain is 0.0024, what is the shortest length of the wire that can be used? So we have given this 3 millimeters. So we have this as 3 millimeters. And therefore neutral axis will be at center. And therefore we have value of y is equal to 1.5 millimeters. That is 1.5 into 10 raised to minus 3 meters, or we can keep it in millimeters. So now we have given data strain 0.0024, y 1.5 millimeters. We have flexural formula like this, and then again we have to go with the same whatever we have considered in last problem with these terms. And then R we are going to get 1 upon epsilon into y. Therefore R is 1 upon 0024 into 1.5. So we are going to consider this in millimeters. So we have in millimeters. And from this we will get radius of curvature as 625 millimeter. So we have actually this as a circle. And from this we are going to get it as a R. And if I know R, then we can find length of this wire, that is perimeter, which is 2 pi r. And then substituting this value 2 pi r, so 2 pi into 625 gives me 3927 millimeter, or I can say it as 3.92 meters. So shortest length of that can be used is 3.92 meter. The last problem we have a simply supported wood beam. AB carries UDL of 6.4 kilonewton meter. Calculate length L of beam if maximum bending stress is 7.29 MPa. So actually it was doubled. So 7.29 MPa. Cross section of beam is rectangular with B is equal to 140, D is equal to 240. So if we will draw the diagram of this, then we are going to get diagram in this fashion. We have this as 140 and this as 240, And if we will plot bending stress diagram, then we are going to get bending stress diagram in this fashion. And we have maximum bending stress, that we have 7.29. Now we will go with given data 6.4 kilonewton meter, sigma 7.29 MPa, B 140 MPa, D for 240 millimeter. Then I will calculate I. We have rectangular section BD cube by 12. So 140 into 240 cube by 12, which gives 161.28 into 10 raised to 6 millimeter to the power 4. Then we have flexural formula. Now here actually we have equal to E by R. But now in this we are going to use only first two terms because this relates with M and I. And therefore we have sigma by Y is equal to M by I. Now sigma we know 7.29 Y. So distance from neutral axis to the farthest fiber. So it comes 120. And this is also 120. Symmetrical, so neutral axis is at center, equal to m upon I, 161.28 into 10 raised to 6. And we will get m 9.8 kilonewton meter. Now we have given UDL. So for UDL, we have bending moment equal to WL square by 8. So we have this as UDL on a simply supported beam. And for this beam, we are going to get bending moment that is equal to WL square by 8. Now we know value of M, we know value of W, we have to find L. So we will put the values 6.4 L square upon 8 equal to 9.8, and from this we will get value of L equal to 3.5 meters. So we have length of beam is 3.5 meters. So these are the three problems which are from your exercise number 1. So remaining we will see in next video. Thank you.